Acids and esters. Carboxylic acids. Carboxylic acids occur widely throughout the plant and animal kingdoms. Acetic acid, butyric acid, higher carboxylic acids such as palmitic acid, stearic acid, etc. are some of the examples of carboxylic acids. The functional group of carboxylic acids is COOH. Depending upon the number of carboxyl groups, carboxylic acids are classified as mono, di, tri, and polycarboxylic acids. Example: acetic acid, that is CH3COO-OH, is a monocarboxylic acid. Oxalic acid, which is C-OH-OH-C-OO-OH, is a dicarboxylic acid. Aliphatic monocarboxylic acids are the compounds in which a hydrogen atom of hydrocarbon is replaced by a carboxyl group. Aliphatic monocarboxylic acids are represented as R-COOH, where R is an alkyl group. They have general formula CnH2n plus 1 COOH. Aliphatic monocarboxylic acids are also called as fatty acids because some of them are obtained by hydrolysis of fats. For example, butyric acid from butter, palmitic and stearic acid from fats. Nomenclature of carboxylic acids. Common or trivial names. Common names of carboxylic acids are derived from the sources from which they were first obtained. Carboxylic acids HCOOH, formic acid, obtained from formica, that is ant. CH3COOH, acetic acid, obtained from acetum, vinegar. CH3CH2COOH, propionic acid, word propion, first fat. CH3CH2CH2COOH, N-butyric acid, obtained from butyrum, butter. CH3CH2CH2CH2COOH, N-valeric acid, obtained from valerian, which is a perennial plant. CH3CH2CH2CH2CH2-COOH, N-caprioic acid, obtained from caper, goat. IUPAC names. In IUPAC system, carboxylic acids are called as alkanoic acids as the name of carboxylic acid is obtained by replacing E from the name of the parent alkane by OIC acid. Following table gives IUPAC names of carboxylic acids along with their common names. Carboxylic acid, common name, formic acid, IUPAC name, methanoic acid. Acetic acid, IUPAC name, ethanoic acid. Propionic acid, IUPAC name, propanoic acid. N-butyric acid, IUPAC name, butanoic acid. Isobutyric acid, alpha-methylpropionic acid, methylpropanoic acid. Isovaleric acid, that is beta-methylbutyric acid, 3-methylbutanoic acid. Methods of preparation of carboxylic acids. From primary alcohols and aldehydes, oxidation. From primary alcohols. Carboxylic acids are obtained from primary alcohols by treating primary alcohols with acidified K2Cr2O7. In this reaction, primary alcohol is oxidized by acidified K2Cr2O7 and the corresponding carboxylic acid is obtained. The preparation of acetic acid from ethanol is given below. from aldehydes. When an aldehyde is oxidized by acidified K2Cr2O7, the corresponding carboxylic acid is obtained. When propionaldehyde is treated with acidified K2Cr2O7, propionic acid is obtained. The reaction is shown below. From alkyl cyanides, that is, by hydrolysis. Carboxylic acids are obtained from alkyl cyanides, alkyl nitrites by hydrolysis. Acid hydrolysis. For example, when an alkyl cyanide like methyl cyanide is boiled with dilute HCl, it gives acetic acid. The reaction is shown below. Alkaline hydrolysis. When ethyl cyanide is boiled with an aqueous alkali like NaOH, it gives sodium propionate, which on acidification gives propionic acid. The reaction is shown below. From dry ice, carbonation of Grignard reagent. When solution of Grignard reagent in dry ether is added to solid carbon dioxide, that is dry ice, it gives a complex which on acid hydrolysis gives corresponding carboxylic acid. For example, formation of acetic acid from dry ice can be given as reactions of carboxylic acids. Carboxylic acids are much weaker acids than mineral acids like HCl, H2SO4 and sulfonic acids, as they dissociate in water, releasing H+ ions. Acidic properties. Acidic properties of carboxylic acids are due to their ability to form H+ ions. Action of active metals. Carboxylic acids react with strongly electropositive metals and the corresponding metal salts with the effervescence of hydrogen gas are formed. For example, reactions of propionic acid with sodium, potassium, calcium and zinc are as follows. Action of alkali. Aqueous alkali like NaOH, KOH neutralize carboxylic acids to give corresponding salts. For example, reaction between propionic acid and KOH is given below. Action of sodium carbonate and sodium bicarbonate. Carboxylic acids react with aqueous sodium carbonate or sodium bicarbonate to give corresponding sodium salts with effervescence of CO2. This reaction is used to identify the presence of acid. Acetic acid reacts with NaHCO3 to give sodium acetate. Formic acid reacts with Na2CO3 to give sodium formate. Action of ammonia. When carboxylic acids react with ammonia, corresponding ammonium salts are formed which on heating decompose to give amides. For example, reaction of acetic acid with ammonia is given as action of SOCl2, PCl3 or PCl5. When carboxylic acids react with thionyl chloride, phosphorus trichloride or phosphorus pentachloride, the OH of carboxyl group is replaced by Cl and corresponding acid chlorides are formed. Reaction of propionic acid with SOCl2 results in formation of propionyl chloride. When acetic acid reacts with PCl5, acetyl chloride is formed. Formation of propionyl chloride from propionic acid and PCl3 is given as action of alcohols. reaction of carboxylic acids with alcohols giving the corresponding esters is called esterification. It is a reversible reaction. Following reaction is an esterification reaction and backward reaction is hydrolysis of esters. For completion of the reaction, concentrated H2SO4 can be used as a catalyst which furnishes H+ ions and also accelerates the rate of esterification by removing water formed. Hence, H2SO4 also reacts as a dehydrating agent. For example, when propionic acid is heated with methyl alcohol at 413 K in presence of concentrated H2SO4, it gives propionic acid plus methyl alcohol in presence of concentrated H2SO4 at 413 K gives methyl propionate plus H2O. Thus, in esterification, water molecule is formed by the combination of H atom of the alcohol and OH group of carboxylic acid. Formation of anhydrides. Formation of anhydrides takes place by condensation of two molecules of the carboxylic acid when it is heated with a strong dehydrating agent like P2O5 or concentrated H2SO4. Formation of acetic anhydride can be given as: the above reaction is reversible. Anhydride formed is very easily hydrolyzed back to acid. In practice, acid anhydride is prepared by heating acid chloride and sodium salt of the acid. Esters. The alkyl derivatives of carboxylic acids in which acidic hydrogen atom of the carboxyl group is replaced by an alkyl group are called esters. Functional group of esters is C double bond O dash single bond O dash. They are represented as R-C-OR1 double bond O, where R and R1 are same or different alkyl groups. Esters and monocarboxylic acids are functional group isomers as both have general formula CnH2nO2. Nomenclature of esters. Esters are obtained from acids and alcohols with elimination of water molecule. Common names. Common name of an ester is obtained by writing the name of the alkyl group of alcohol part followed by common name of the parent acid and then replacing the suffix IC acid by ATE. IUPAC names. IUPAC name of an ester is alkyl alkanoate. The following table gives common names and IUPAC names of some esters: ethyl formate, ethyl methanoate, ethyl acetate, ethyl ethanoate, ethyl propionate, ethyl propanoate, methyl propionate, methyl propanoate. Methods of preparation of esters from alcohols and carboxylic acids. Formation of an ester when an alcohol is heated with carboxylic acid in presence of dehydrating agent like concentrated H2SO4 is esterification. For example, reaction of propionic acid with ethyl alcohol results in formation of ethyl propionate. The reaction is given below. From alcohols and acid chlorides. When an alcohol reacts with acid chloride, hydrogen atom of hydroxyl group in alcohol is replaced by an acyl group, that is CO-R, and the corresponding ester is formed. For example, when propionyl chloride reacts with methyl alcohol, methyl propionate is formed. The reaction is shown. From alcohols and acid anhydrides. When an acid anhydride is refluxed with an alcohol in presence of pyridine, hydrogen atom of the hydroxyl group in alcohol is replaced by an acyl group and the corresponding ester is obtained. Hence, this process is called acylation of alcohols. For example, reaction between acetic anhydride and ethanol can be given as from silver salt of carboxylic acid and alkyl halide. Formation of ester takes place when silver salt of carboxylic acid is heated with alkyl halide. For example, formation of methyl acetate is given as reactions of esters. Esters undergo hydrolysis rapidly in acidic or alkaline medium, but slowly when heated in a neutral medium. Acidic hydrolysis. When an ester is heated with aqueous acid, it undergoes hydrolysis to give the parent carboxylic acid and alcohol. For example, the reaction of methyl acetate with dilute H2SO4 is given below. Alkaline hydrolysis. Alkaline hydrolysis of esters is called saponification. When an ester is heated with an aqueous alkali like NaOH, it undergoes hydrolysis and a salt of parent carboxylic acid and alcohol are formed. For example, when methyl propionate reacts with NaOH, sodium propionate and methyl alcohol are formed. Action of Grignard reagent, formation of alcohols. Reaction of esters with Grignard reagent in presence of dry ether as a solvent first gives the corresponding aldehyde or ketone. This aldehyde or ketone reacts with the excess of Grignard reagent to give a complex which on acid hydrolysis forms corresponding alcohol. Action on alkyl formates. Example, methyl formate reacts with methyl magnesium iodide in presence of dry ether as a solvent to give first acetaldehyde. Acetaldehyde then reacts with another molecule of methyl magnesium iodide to give isopropyl alcohol. See the reactions shown below. Action on esters except alkyl formates. When esters except alkyl formates react with Grignard reagent in presence of dry ether as a solvent, the corresponding ketones are formed. These ketones react with excess of Grignard reagent to form the corresponding tertiary alcohols. Methyl propionate reacts with methyl magnesium bromide to give a ketone, butan 2,1. Butan 2,1 then reacts with another molecule of methyl magnesium bromide to give a tertiary butyl alcohol. Uses of esters. They are used as solvents for oils, fats, gums, resins, paints, etc. Esters of higher fatty acids, that is oils and fats, are consumed as food and are used to prepare soaps. Ethyl acetate is used as a solvent in making smokeless powder.